Okay, so I wanted to share with you a cool trick that I came across that helps save money in the labeling stage using clustering, as the name suggests. This is the problem we are facing. We have a law firm that has a lot of contracts, but they're not labeled. And what the law firm wants to achieve is to be able to classify all of those documents into one of three clusters, A, B, or C, one of three classes, A, B, or C. Now, labeling a contract is not cheap because lawyers aren't cheap. And a lawyer needs to read a contract in order to label it. On the upside, contracts are very similar to one another. So lawyers love the copy-paste, but between us. So let's try and take advantage of this fact. This is the idea. First, we try to cluster contracts together. Then we try to take one example from each cluster and let our expensive lawyer label it, and then saving money. So the first stage we need to take is to take a document, a contract, and convert it in some magical way into a vector. Now, there are a lot of ways to do this. The most simple one is just to count how many words are in each document, and then you have this large vector, the size of the vocabulary. Other more sophisticated ways, for example, TF-IDF, also account for the frequency of words. Maybe words like the, of, and aren't as informative as other words. Other methods there are a lot of neural networks method. I don't want to elaborate more on this. Just you need to have a method to take your contract, take your document, and convert it into a vector. This is a three-liner in SkLearn that does TF-IDF for you. If you only want the counts, then use the first two lines. Very easy, very straightforward. Next, we want to cluster all of those vectors that we built together. Now, usually when people think about clustering, they think about k-means. K-means is a top-down approach, meaning that you assign k clusters, k centroids, and then you shake them and move them around in some magical way, and at the end you get a division of the space into k clusters. The other approach is called bottom-up. You start with n clusters, n being the number of documents, and then you start to merge them together according to distance, one by one. At the end of this process, you need to decide when to stop, what is the minimal distance that is still important. And you get a variant number of clusters. This is how you do hierarchical clustering in Python. Pretty simple. SciPy has a very easy implementation for it. Hierarchical clustering has three hyperparameters. The first is what distance do you use? There are a lot of choices in SciPy. Next is what is the minimal distance that you need to account for, the minimal distance that you still consider things to be in the same cluster. This is called the cutoff distance. And the last hyperparameter is where do you measure the distance from? Do you measure it from the center of the cluster? Do you measure it from the bound, for the furthest point? Once we decided on an embedding method and a clustering algorithm, we have clustering, and now we want to evaluate it. So there are a lot of ways to evaluate clustering algorithms in the general sense. But in this context, we want to find the best cluster that will help us label the data. So a neat way to look at the clustering algorithm is in this table. In this table, we asked the lawyer to label a small sample of the documents, and then we saw how a clustering algorithm works on this on the labeled data. For example, in the first table, we can see that cluster 1 has two documents that are labeled as A. Cluster 2 has two items labeled as B, and so on. And what we want to achieve, we have two objectives that we want to optimize for. One is that we want as little clusters as possible, because the more clusters, the more work our lawyer needs to do, and thus we pay more. The second one is that we want as little collisions or no collisions as possible. For example, here, cluster 1 has 2 types of labels, which means that one of those labels are going to be mislabeled, and then our whole model is going to suffer from this issue. Next, regarding results. So we applied this method on 35,000 documents, and we were very picky regarding, we didn't want any labeling error. And we got 50% reduction in labels. So 50% less money, and we are all happy. It runs in a matter of minutes or less, depending on your data, but it's not something that you need to run overnight. And you can see here that actually the clusters make sense. So this is only like the first 3 examples out of, I think it was 13. All those clauses actually talk about the same thing. They talk about counterparts or whatever legal mumbo jumbo. Okay, to summarize, we've seen how to do hierarchical clustering in Python using standard SciPy and SkLearn. The hyperparameters you need to play with are how do you embed your data, how do you embed the document, how do you convert the document to a vector, how do you measure distance, and what is the cutoff, and where do you measure distance from? How to evaluate. We set 2 objectives that you can optimize for, depending on how sensitive your labeling is. And we achieved 50% reduction without sacrificing any accuracy. Questions?
So I didn't understand the evaluation process. Do you have, where do you get the labels from? From like the lawyers tag all the documents in the cluster?
So it's evaluation in retrospective. We have to ask the lawyer to tag a small sample, so we'll know we're in the right direction. Just to repeat the question, the question was, how do we get the labeled data from? Because if we have the labeled data, then this whole exercise is meaningless. So we ask our lawyer to label a few of the data, like a small sample, 10% or even less. Then we can evaluate our clustering algorithms and choose the best one.
If you have a sample of labels, why not just build a model based on that, take the top features from the model and the output, predict the probabilities and cluster based on that? I mean, it would be a lot more optimal for that.
So the question was, well, if we have labeled data, let's just train classifiers and then derive the clustering algorithm from that. So actually, we might cover just a small sample of all of potential labels that we might have, or all of potential. For example, let's say that we have 10,000 types of classes, and our sample only have 5,000. So it's best just to make sure that in what we can see, we are not making any mistakes, rather than training classifiers in advance. Any other questions? So the question was, how do I know that the clustering is good if I first cluster and then ask the lawyer to label it? So only for evaluation purposes, which is important, I ask the lawyer to classify 10% of the data or even less, and then using that 10% of the data, I adjust my clustering algorithm. Okay, we're out of time.